Hey, good morning, everybody. So today is Monday, October 26th. We are going to look today at graphing linear functions and talking about slope-intercept form. So you should recall this from last year, so hopefully this is just a review for you. But regardless, after today's video, it should make more sense. So looking at the first one, it says Desmos graph from a table of values. Use the table below to graph the linear function y equals 3x minus 2. All right, so just real quickly as a quick refresher, in Desmos you can, and I apologize for working on some other stuff here, you can just type in the equation, of course, y equals 3x minus 2 in Desmos, hit this little home button off to the right, okay, and it'll give you the equation including where it crosses the x and y axis, right? So that's a pretty cool little feature of Desmos. You can just type it in to make sure that you have the correct graph. So that's going to be important here going forward. So on this first one, let's just use a table though. We're going to graph it by hand at least initially. So we have these x values. These are our input, right? These are our output. Okay, so you recall domain and range. We're going to talk about that here again in a second. All right, and here's our equation. So remember that our input goes into the equation and then our output comes out of it, right? So our input in the first one is negative 2. So we have y equals 3 times negative 2 is our x value that we're plugging in. Okay, and then we're just going to simplify this. So 3 times negative 2 is negative 6. Negative 6 minus 2 is negative 8. So our y value is negative 2, or our x value is negative 2, our y value is negative 8. So let's go ahead and plot that. Negative 2, negative 8. Okay. Next one is negative 1 that we're going to plug in. So same thing, y equals 3 times negative 1 minus 2. Okay, 3 times negative 1 is negative 3. Minus 2 is negative 5. Okay, so negative 1 and negative 5. So negative 1, negative 5 is right there. Plot that point. Okay, 0. So 3 times 0 minus 2. Anything times 0 is just 0. All right, I'm going to finish the table here, and then I'll plug in the rest of the points. 3 times 1 minus 2 gives you 3 minus 2, which is 1, and 3 times 2 minus 2, which is 6 minus 2, which is 4. So we have 1, 1, and 2 4s, and 0, negative 2. So 0, negative 2, 1, 1, 2, 4. Cool, awesome. All right, so you can see these points. They do, in fact, look like that line that we just graphed in Desmos, which is fantastic. All right, how is the graph different from a graph of an arithmetic sequence? It has solutions, or we'll say you draw the line connecting the points. That's what we'll say. Because it is a linear function, so that means even though, so a linear function, even though these are the only points listed, there are actual more points in between as well on the line. So since it's a linear function and not just an arithmetic sequence, we're going to draw the line connecting each point, which means, again, that there are solutions in between each of those points. We just didn't list them in the table. Okay, so what's the domain of this function? So remember that domain is our x values, possible x values. So how far does it go left and how far does it go right? In this particular case, since there are arrows, it'll continue to go left and right all the way up and all the way down. So our domain of this function is negative infinity to infinity. Or if you wrote it in interval inequality notation, it would look like this. Okay, what is its range? Well, same thing. It's going to continue to go up and continue to go down. So negative infinity to y to positive infinity. Okay, or again, same thing, negative infinity to infinity. Okay, use the table to graph each of these linear equations. Graph them on the same coordinate point below. Okay, so I'm going to use the x equals 5 as red. So if x equals 5, okay, well that kind of tells us what we need to plug in, right? X is 5. It doesn't change. Okay, now it doesn't tell us what the y values are, so let's just plug these in. You can pick any number for y since it doesn't tell us. Okay, and 5, x is 5, so 5, 6, 5, 7, 5, 8, etc. And that is a straight line, straight vertical line on x equals 5. Okay. All right, so what's the domain of this one? Okay, so again, how far does it go left? How far does it go right? Well, it doesn't go left or right. It stays at the same spot, right? So our only domain, our input, there's only one of them, 5. That's it, because it doesn't go left or right. How about the range? Well, the range, it clearly is a vertical line. It's going to continue to go up and down to infinity. So our range is negative infinity to infinity. Okay, what's our slope? Well, this is a vertical line, so like what we talked about before, if you remember slope, dude, this one is undefined. Okay. Okay, how about y equals negative 2? So change the color here. Y equals negative 2, so negative 2 is the y at all times. Means the x values can change. Okay, so negative 2, negative 2, negative 2, straight line, horizontal line right here at y equals negative 2. Again, remember that this is your x-axis, this is your y-axis. Okay, so what is our domain here? Well, where does it go left and right? Okay, well, constantly is going left and right, so this would be negative infinity to infinity. What's our range? Our range, it never moves, so this would be negative 2. All right, what's our slope? It's a horizontal line, so this is a 0 slope. Okay, and if you're not sure how to get those, don't forget that you could pick 2 points. Pick 2 points and do our y2 minus y1 over x2 minus x1. You could pick 2 points and do that as well if you need to figure out the slope. Okay. What is the domain and range of most linear functions? What are the exceptions to this? Okay, so that question is kind of a loaded question, because if we look at just these, it looks like they kind of flip around, right? So you would say, well, domain is negative infinity to positive infinity, or flip-flops. But recall that we did the first one, all right? And so the first one, both the domain and the range were negative infinity to positive infinity because it's a linear function, so it continues on forever in both directions. So it's the same way for most linear functions. The domain is typically negative infinity to positive infinity. The only exceptions, same for the range, the only exceptions are horizontal or vertical lines. Okay, and those are the ones that we just did. So you can see, instead of domain being negative infinity to positive infinity, okay, it stops because it doesn't have this like slight angle that causes it to go up in both directions. Okay, so horizontal, blue, vertical lines, they're the only exceptions to this domain and range, constantly being negative infinity to positive infinity. All right, so let's look at a real life example here. A puppy weighed 5 ounces at birth, gained weight at a constant rate of 3 ounces per week for the first 8 weeks. Use the table to graph the puppy's weight during the first 8 weeks of life. Okay, we are going to change this right off the bat because this says negative 2. Well, that doesn't really make any sense, right? Because you can't have negative 2 weeks. So let's go ahead and rewrite these as 0, 1, 2, 3, 4. Okay, now if we did it correctly, then he should be 5 ounces at birth. So plug in your 0 into that equation. Sure enough, you get 5. Perfect. Okay, so let's go ahead and continue to fill out this table. Jumps to 8, 11, 14, and 17. So as you notice, it starts at 5 and it goes up by 3 every time, right? Well, that's exactly what slope-intercept form is. Look at this equation right here. So we have starts at 5 and then the slope goes in front of x. That's how much it increases by every single time. Increases or decreases. Okay? So, what is the domain of this problem? Well, since it constantly changes, we already know, we don't even have to graph it. It's a linear function. It's negative infinity to infinity. Same for the range. Okay, what is the slope? The slope is what it goes up, okay, by what it goes left and right. So this is 3 over 1. Can you think of another problem that would have a limited... and I'm kind of dumb here because the domain and range would not go from negative infinity to infinity. I know what this question's asking. It says, can you think of another problem that have a limited domain and range? Okay, this is limited, and it's not negative infinity to infinity, even though it's linear, because it's a real world problem. And what domain value do we have to start with? 0, right? We cannot start at negative weeks for the puppy. Okay, what is the range? Okay, the range is what's the first ounce that he weighed? 5, right? So this is 5 to infinity or until, unfortunately, he's no longer with us. Okay, so there's your domain and range. So can you think of another problem that have a limited domain and range? You know, think about that to yourself. In the meantime, I'm going to go ahead and plot this. So if this is 1, 2, 3, let's go by, that'll work. 2, 3, 4, 5, 6, 7, 8. I'm just going to list every other now. Okay. And that gets us to where we need to be. So 0, 5 is the first one. 1, 8 is the second one. 2, 11 is the next one. 3, 14, and 4, 17. There you go. So, and yes, I would draw a line on this one because the puppy's not just going to gain 3 pounds after a week. He's going to gain some weight in between. So there are going to be solutions in between there. So that's a graph. Okay, so again, slope-intercept form, we kind of touched on it right there in the graph. Slope-intercept form of a linear equation, you probably remember from last year, is y equals mx plus b, where m is the slope and b is the y-intercept. Okay, it's also known as the starting point. Okay, or initial value. So sometimes when you're talking about bank accounts, they'll say the initial value in the account, right? So that would be your b value. Okay, so when you graph a line in slope-intercept form, you get the equation like this, where y equals the rest of it. So you want to solve for y, make sure y is by itself, identify the slope and the intercept. The slope is always the coefficient that's being multiplied by x. So this would be 3/5, 3 over 5. Okay, and then your y-intercept is the constant that's by itself. Okay, which is the positive 2. So first you're going to plot the y-intercept, then you use rise over run. So you start at 2, and then rise over run tells us you go up 3 and right 5. So up 1, 2, 3, 1, 2, 3, 4, 5. Okay, now you always want to plot 3 points. So if you get to this point and you don't have enough, you have to go backwards. So instead of up 3 and right 5, you can go down 3, 1, 2, 3, and left 5, 1, 2, 3, 4, 5, because that's a complete opposite, right? So this would be a positive over a positive, which is a positive in terms of the slope. And this would be left 3 and down 5, 2 negatives also make a positive, so that's what makes this able to be a straight line. Okay? All right, so let's go through 2 more examples here, and then I'll let you start the exit ticket. So if every time you're given this and it wants you to graph it, let's list the slope and the y-intercept. In this case, the slope is 1/4, y-intercept is 1. So we're going to start at 1, and we're going to go up 1 over 4. Okay, and then we're going to go down 1 and left 4. And as you can see, that gives us our line. Okay, same thing here. What's our m? Okay, well, it says -2, but remember that we want rise over run, so that would say it goes down 2, but which way does it go? Well, we can put this over top of a 1, because -2 divided by 1 is still -2, and that gives us a fraction that we can use for rise over run. So this is going to start at a positive 2, and it's going to go down 2, right 1, down 2, right 1. And as I mentioned, you want to always have at least 3 dots on your slope-intercept line. Okay, so that's linear equations. That's how you graph them. First find the slope, then find your y-intercept, plug them in, and just like we did before, do your rise over your run. So down 2, right 1, down 2, right 1. All right, guys, let me know if you have any questions. In the meantime, finish up the exit ticket tonight, and I will see you in class.